Welcome back. It's CTF time, and therefore I pulled out my black hoodie and we are going to take a look at this very hard reverse engineering challenge. You can find this over here, and I highly encourage you to register yourself on this website and also take a look at the other challenges. Maybe after this course, because then I have weaponized you with all the skills and knowledge on how to solve them. In my case, I already did this, I guess, 2 years ago. And this is not a flex, this is something you might expect from me, right? Absolutely, and I'm glad that I didn't disappoint you right there. The challenge we are going to solve with the FlowGraph is the UPOS challenge. And this is also the challenge with the highest amount of points and the least amount of solvers. So this is definitely the hardest challenge in this whole box right there. But what makes this challenge that hard? It all did start with the APK itself. My first attempt was, okay, let's try decompile this application and get the Java sources out of this. I opened up my terminal and neither JADX nor dex2jar was able to compile or decompile those classes.dex files. Therefore, I didn't have a Java source code right there. And this was the time where I was looking for a different decompiler than JADX and dex2jar, and I found one, the DAD, within the Androgard tool. And finally, Androgard was able to decompile this application, and I was like, great, maybe this is the hardest part in this challenge, to decompile this application and get back those sources. Well, I was completely wrong about this, because after decompiling this application, I did end up with a bunch of methods. There weren't that many, I guess 3 or 4, but one method was really huge. And this method did look like this, multiplied by 20 times. So this method was full of branch instruction. We get our input, we pass it into a function, and then we got tons of branch instruction. And you have to think of this. One leads to this, and one leads to this, and then we've got these, and then over these, and this multiplied by, 20. And finally, in between all those branch instructions, there's this one single solution which we have to reach. But there were some little sneaky branch instruction in there. It's not like that always the true path is the correct one. Sometimes there were checks like, does this flag contain the following value? For example, UPOS. And you were like, oh, okay, maybe UPOS has to be within our input. And you followed the correct branch instruction, but it was the left one, the false branch instruction. And things like this. I guess there were also some anti-debug mechanism there. If you hooked up Frida and tried some runtime analysis, the application behaved in a different way. So this one was ridiculous hard. And after staring at this Java source code, I was like, okay, it's not possible for me to solve this challenge by staring at this Java source code and figure out which branch instruction leads to the final solution. The solution itself, by the way, was not really hard to identify because there was this really long hash and your input gets modified during all those branch instructions. Afterwards, the input gets hashed and those two values get compared. So where we have to go, this was pretty clear. But how do we get there? Absolutely not. And therefore I figured out, okay, for me the only way to solve this is creating a flow graph. And you will see the benefit afterwards if you have this, and we can then eliminate all those sneaky and wrong branch instructions, and afterwards we end up with a clean way. This isn't that easy as it sounds because this takes time. I guess it did take over 1 hour to eliminate all those wrong branch instructions. But these are the two main keys, patience and time if you reverse engineer Android applications. Alrighty, the last thing I want to mention is the FlowGraph contains only Smiley instructions. So we do not get our Java source code in this FlowGraph, we do get our Smiley source code in there. For me at this time this was no problem because I was pretty familiar with the Smiley. But if you want to solve this challenge afterwards, you might have to wait until we have finished the next chapter where we learn Smiley if you're not familiar with this. Of course, if you already know Smiley, then feel free to go ahead with this approach and try solving this challenge. And let me know about this if you could solve this with the FlowGraph. But please don't ask for a solution. I'm not going to provide you the solution for this, okay? The last funny thing about this challenge was, after I have solved this, I talked with the author about this. And the author did also mention that he did not expect that a decompiler is able to decompile all those Java sources. But even by having these Java sources, I did not get any benefit out of this because the FlowGraph itself, which was the main concept in solving this challenge for me, was written or has this instruction in Smiley. So even if I did decompile this application, I did not get any advantage. So this was pretty ridiculous for me. But it's super nice to see that different decompilers give different results. So if you struggle with the decompiler, try different tooling. For example, Dex2Char, JADX, and now also AndroGuard. Maybe one of them is able to solve it, or maybe one does better than the other. So yeah, please try different tools. Maybe one of them is able to solve this task. Alright, next we are going to have a look in this challenge. We are going to download, install it, and then we take it apart. But only until we get to the point where we have created this flow graph, because I do not want to spoiler any further. Okay, here we are now at our Ubuntu VM, and if you want to download this challenge, then please go to this website. This is the website of the author, and you can find those challenges over here. By the way, the author also put in some amazing slides which you can find over here, so definitely also have a look into this one if you are interested in a certain topic, which is super nice from the author. Okay, you can find the challenges here, and then you have register on this website with an email account, and then you can finally download this APK file. I'm not able to provide you directly this APK file because I would circumvent this whole mechanism of the author, and this is something I don't want to do. The author did put a lot of work into those challenges, and it would be absolutely fair if he at least leave a registration for his website over here. Alright? Okay, you can pause this video and yeah, register your account over there and download this upus.apk file, and then you can move on with the video where I explain on how to create all the stuff. Or you can just lean back and watch me doing this. So I'm going to close this one, and yeah, I already downloaded this file. It's within the downloads directory, and here we have it. I copy paste it, and we create a new directory over here, and we name this Upus challenge very hard. Alrighty, let's start decompiling this Android application with our Dex2Char approach. Let's see how good this goes. No, I don't want to update right now. And therefore we have to unzip this to get those classes.dex file. Here we have them. We've got two. So I would assume our interesting source code is over here in classes2.dex. Dex2Char. And here we have our classes2.dex char now. If we run jdgui, we can see we have a code over here. Let's figure it out. Yes, Dex2Char is still not able to decompile all those methods, as we can see right here. So this one is the check flag method, and we can see we only got this Java bytecode over here. So we cannot do anything with this right now, okay? Maybe not okay, but we do not have a choice. All right, let's try JADX. JDX GUI on those Upus APK. And yes, JDX GUI seems not to be able to decompile anything, but this is an error which is regarding to using the wrong Java version. So in the last video we have changed the Java version. Let's check this real quick. Yes, we've got Java version 8 already installed, or not installed, already in use. We have to switch back to Java 11 if you want to use JDX GUI. Alright, so sudo update alternatives --config Java. Yes, and then I select version 0 to use the Java 11. And we also have to repeat this for the Java compiler. Also 0, okay. Now it should be fine. Yes, now we are back on Java version 11. Let's try this again. Yes, okay, this is the window which we should at least get. So if you get a blank window over there, then it's regarding to an outdated Java version. It's annoying, I know, but unfortunately we have to deal with this. Okay. Let's see if JDX is doing this. So we can see also JDX is not able to decompile this code. All right. Now let's try AndroGuard. AndroGuard --help. And here we have this decompile. AndroGuard decompile --help. Yes, and here we have now the options of Androguard decompile. We can see, for example, we can define an output directory that contains then our Java source code. So Androguard is decompiling those classes.dex with the DAD decompiler, which is also mentioned here, and creates those single Java class files in this output directory. And this one we will take a look in a few seconds, because this is now the flow graph we can create with the decompiled code together. Okay, but for now, let's only try decompiling this application. Androguard decompile and then upos, and we have to provide an output directory. I simply named this out because out is not available over here. So we didn't create this directory yet, but if we provide it as a parameter, then Androguard is going to create it and stores all this function and decompiled code into this. Alrighty. This might now take some time because it's a lot of stuff going on there, and I will come back if this decompilation process has been finished. Now the decompilation process has been finished, and let's figure out what we've got here. Okay, I'm going to open this in a file browser, then it's easier to see. This seems to be our main package names. We've got Android, Android X, and COM. So I would assume our code is within COM because this sounds like the developer path. Mobisec, upos, and there we go. We've got Java files, but we do not know how good they are right now. We've got also this directory, and here we've got some HE files. We will take a look into this later on. Okay, here we have now the flag check Java file. Let's try opening this. I open this in a terminal over here, then we are in this directory, and I use a gedit, for example, FC Java. Okay, and here we can see this looks like, yes, this is Java code, nice. So Androguard is able to decompile this file. We have this check flag method over here, and this is all Java code right now, and you can see all those branch instructions already and the sneaky traps. So our input might have to start with Mobisec or might not. We do not know right now. You have to go down the whole rabbit hole, and you can see there's a lot of stuff going on. If we scroll through all these instructions, and here we can see this one is the final hash that our input gets hashed and compared against afterwards. But this is not the end right here, so I guess, yes, there's a lot of stuff underneath this. So there are some jump instruction upwards and things like this. You can try solving this with this Java source code, but you would go absolutely crazy. Therefore, we are going to create a flow graph. But first, let's install and run this application and have a quick look in how this looks like. The view itself is pretty clean and easy, and but it's good to know what we have to deal with. So therefore, we go into our apps directory, upos challenge, and we are going to make our connection via ADB. Alrighty, then we do ADB install upos.abk, and we are also going to get the screen over here. Here we've got this upos application. I'm going to start this. And as already mentioned, we have to provide this flag over here, and then we have to check this flag. Okay, going to close this one and clean this up real quick. Okay, now we want to create a flow graph for this application. So let's have a look at the official documentation of Androguard, because we don't know how to do this right now. Therefore, we go into our web browser of choice, Androguard decompile, and we take a look at this documentation. Because within the decompile command, we have seen this -f option, additional write control flow graphs for each method. The format is in PNG, JPEG or RAW, which means a dot file. Alright, if we scroll down a little bit, we can see the examples, and there we have an Androguard decompile -o output folder. This is absolutely familiar to us. Then we've got this -f option, which means, okay, write this control flow graph as a PNG file. We have to provide our APK, and then there's also this nice parameter, which is limit. In the last section we have seen we've got about 25,000 methods in our APK. And if we are now going to create a control flow graph for each method which an output as a picture, this will take up to an hour. Therefore, we can limit the output to just a certain class names that we do not have to decompile and provide pictures for every method in this application right now. And this is a regular expression over there, so we can define the beginning of our class name. And I'm going to show you what this looks like for our case. So if we go into this UPOS challenge back again, and we can also use JDGUI to open this classes.dex to char, because we do not need the method name, we just need to know the class name. And here we can see we've got this Android package, which we are not interested in. We've got this Android X package, which we are not interested in. And then we've got this com mobisec upos. And we only want to filter or provide those call graphs for these functions over here. Therefore, we provide our filter for this package name. And here we have the regular expression for this. The first char needs to be this big L, which is the type definition in Smiley. For now, there's a class name. In our case, it's not com elite, it's com/mobisec/. We can also provide upos in our case, but mobisec would be enough to only decompile and provide those control flow graphs for these classes in this package over there. All right, we can also see we have to install two additional dependencies. We need to have GraphWiz and PyDot installed. Let's do this real quick. So we run sudo apt-get install GraphWiz. Yes. And regarding to the PyDot, we stick to our Python 3 version because AndroGuard needs Python 3 and therefore we are also using pip3. Pip3 install, upgrade those packages, PyDot. Okay, both have now been installed. We can now create our first flow graph. So therefore we go into apps. This is the UPOS challenge. And we create a new directory, I would say. Yes, we create a new directory. So we say AndroGuard decompile --help. And now we say AndroGuard decompile. Let's see. Our new directory is now upos_cg for control graph. Oh no, it's FlowGraph, therefore FG. Then we provide our format, which is PNG. And we want to limit it to the beginning, this way, of com/mobisec. All right, this should work. Let's see. Give one file to decode. That's right. We have to provide our APK, of course. This should work right now. Okay, it's starting decompiling this, and even for these least amount of methods, this might take a while. So I will be back if this process has been finished. All right, finally this process did finish. And this weren't that many methods. Now let's imagine if we have decompiled this whole application and created a flow graph for all methods. This will take quite a while, I guess up to an hour. So let's see what we've got here. I'm opening this in a file browser. And this one over here, upos_fg. We've got now com mobisec upos. And here we've got now still those AG files. I'm going to show you this. How they look like. Let's see. This, for example. So here we've only got the decompiled output, like if we have done this with dex dump. This is just the output which is stored in there. It's pretty helpful if you want to go through this, but yeah, I guess we are not ready for this right now. We will learn on how to do this, but yeah, not yet. Okay, beside this, we've got now these pictures over here. Let's figure out where's our flag check. Okay, at the beginning we've got this class name and then we've got this method name. So let's have a look back real quick. We can also use this one which was not able to decompile it. Okay, we should have an FC file name with a check flag method. So it should be here, let's see. Here we have this. So if we search for check, it's easier to find. I didn't see this one right over here. Okay, and now we can open this. I recommend you opening this with GIMP because this file is really large. You can see this is 32 MB large, which is ridiculous for a picture like this. And yeah, the best way to open this is using GIMP because otherwise you might run into trouble. So we open a new terminal over here and then we say GIMP and we use FC and I hit the tab button multiple times and now we have to search it again. Oh, it's at the beginning. That's maybe the reason why I didn't see it. Okay, now GIMP is opening this file right now and we can see it's loading slowly. Let's see what we get at output. Okay, here we have now finally the output of this file, and if you zoom in you might think, ooh, this looks absolutely like a mess, all those lines over here. But you can also see the whole branch instruction and yeah, how ridiculous this challenge is. So if you scroll down, ooh, well, it doesn't get even better, and yeah, we can see this looks absolutely like a mess. But it's impressive how good you can deal with this file. So if we scroll down a little bit, ooh, it seems to get worse. And there we've got a huge blob. So let's figure out what this one is here. These are all Java exceptions. So if we end up here, we might be definitely wrong. And yeah, this is a good starting point because we know if we reach to this level, if we get to one of these, we are wrong. Therefore we can exclude all of them already. But let's figure out where's our solution. And already here we found this. So here's our solution. We need to get to this point over here. And this is really not that hard to find because you have to look at the end of this file and there are not that many blocks. So you have to go from right to left and then you finally retrieve this one. It could be also this one or this one, but that's all. It's not buried in between those over here because then we would have reached this block much earlier. All right, nice. So now we know where we need to go. And yeah, this is Smiley and we do not understand Smiley right now. But we can see we've got a green and a red line and we've got this if. We do not know that NEZ stands for not equals 0. So we just know, okay, there's an if statement and the green one is the right path and red one is the wrong path. But it doesn't even matter at this point for those two, because if we reach to this point over here, we already have our flag compared against this value. So at this point we know if our flag is correct or not. Therefore we can ignore all which is underneath this. And we can graphically illustrate this by creating a new layer. So we click new layer. And you can see this file is absolute enormous big. So you might want to increase your RAM of your virtual machine to view this. Okay, now we've got our layer and now we can drag our pencil into this. I choose yellow because green, red and blue are already chosen. Blue is, by the way, a single path. So if we have a branch with true or false, we've got green and red, and blue is a single instruction, a single jump, this way. Okay, so now we can tell, okay, this one here, we need to get over here. You can adjust the size of the brush over there. So let's see, we make this a little bit smaller, maybe 8. Therefore, we can ignore this, and we can also ignore all those Java exceptions at the bottom. This means we have to go to this one. So let's see where we end up here. We've got this wrong statement. This wrong statement leads to this one, and this leads to our exceptions over here. We can eliminate this completely. There we've got also an exception, and here we've also got an exception. And then we've got a true statement over here, and this one, and this one. Oh, sorry, this one we have to take care about. Interesting. This one over here, let me clean this up real quick. This one, yeah. This one got a back connection over here. So this block has the ability to go back this way until we hit our block. Okay, so we might have to take care about this block. The wrong statement also. So we have to take care about the wrong statement because this wrong statement can up in this true statement, and then we can go back to this one. All right, so this block is important for us, and this block is also important for us. You have to choose, I guess, different colors for this to eliminate things and accept them. So let's take red to eliminate them. I guess that's a better approach. Okay, so now we know this one. Let's figure out where we do get here. So here we can get over here. Therefore I choose the yellow part again. This block is important. This block ends up here, which is this one over here. Okay, this one is also important. This one is not important. No. At the first look, this one seems not to be important, but we can mark this differently, that we have to take a closer look later on this. And by doing this, we end up on the final solution. And by tracing this back, this takes a while. But here at this block, you can already see the benefit of this. Let's see. So we've got this one over here. This one green. So here the true statement is important. And this means this one can be eliminated. This one is not relevant. This one, default statement, is not relevant. So we have to go to this one, this green one. Then we have to go to this block. And then we have to go to this block. So at this block, we definitely know the false branch is the wrong branch. And so we can trace this back. And you can see we did not make that much progress. Or it's okay, I would assume. There's a lot of work still we have to do. But it's possible, or in my case, the only solution to do it in this way. Because if you stare at the Java source code and get all those curly brackets, it's a super mess on how to do this. This looks also messy, but if you try this challenge with this approach, you will be definitely able to solve it. Alright, that's all about the call graph. I'm not going to spoiler further the solution right now. If you have any question about this topic, write me a message. I'm super glad if I get feedback on this. And otherwise, we have a last section until we get to this large chapter in our course, this Mali part. And afterwards, then we will be able to understand what's going on there, what all these instructions mean, which is super ridiculous nice and gives you unlimited power in hacking Android applications. So I see you there.